Welcome. In this short walkthrough, we'll look at Paper2Video, a system that takes a research paper as input and produces a complete presentation video. Slides, narration, cursor cues, and even a talking head of the presenter, entirely automatically. The work comes from Sholab at the National University of Singapore and was accepted to the Scaling Environments for Agents workshop at NeurIPS 2025. Making a good conference video is genuinely a lot of work. You have to distill your own paper into slides, write a script, record a voiceover, sync a cursor or laser pointer to the right region of each slide, and then film yourself or splice in a talking head. For most researchers, that's many hours per paper, and the quality varies wildly because most of us are not video editors. Paper2Video argues that an agent can take care of all of this for you. Paper2Video has two pieces. The first is PaperTalker, an agent that integrates slide generation, subtitling, cursor grounding, speech synthesis, and talking head rendering into a single pipeline. The second is a benchmark, also called Paper2Video, with new metrics designed specifically for academic presentation videos, where the goal is communicating scholarship rather than visual fidelity. The inputs are simple paper, a portrait photo, and roughly 10 seconds of reference audio. The pipeline runs in 5 sequential stages. First, slides are generated from the LaTeX source. Second, subtitles. The narrative script are written by a vision language model that also figures out where on each slide the cursor should be highlighting. Third, speech is synthesized in the author's own cloned voice. Fourth, the cursor track is rendered. And fifth, an optional talking head video of the presenter is generated and composited on top of the slide deck. In stage 1 and 2, a language model writes Beamer LaTeX for each slide, and a tree search procedure picks the layout that best fits the content without overflowing the page. Then a vision language model reads each rendered slide image, writes a short narration paragraph describing what's on it, and tags which region of the slide should be highlighted while each sentence is being spoken. In stage 3 and 4 and 5, TTS clones the author's voice from roughly 10 seconds of reference audio and reads the narration in that voice. In parallel, the cursor module places a moving pointer on the slide that follows the bounding boxes the vision language model produced earlier, so the audience's eye is led to the right region exactly when it is mentioned in the narration. Stage 5 is optional. If you provide a square portrait of yourself, the system uses Halo 2, a portrait animation model, to synthesize a talking head video that lip syncs to the generated speech. The talking head is then composited as a small overlay onto the slide deck, exactly the way a real recorded conference talk looks on screen. On the evaluation side, the team argues that conventional video generation metrics don't really apply, because a presentation video is judged by how well it communicates research, not by how photorealistic it looks. They introduce 4 metrics. Meta-Similarity compares against the author's real video. PresentArena is a head-to-head pairwise human comparison. PresentQuiz tests whether viewers can answer comprehension questions after watching. An IP memory checks whether the author's identity comes through. Running it is a single command. You point pipeline light by the LaTeX source of your paper, give it a reference portrait and a roughly 10-second voice clip, set your API keys and list which GPUs to use. With the talking head stage off, generation is fast and runs on modest hardware. With it on, you'll want at least an A6000 class GPU and Halo 2 installed in a separate Python environment. Before we wrap up, here's a quick look at what Paper2Video actually produces. Coming up next, about a minute of a real generated presentation. Welcome everyone. Today I am presenting KALEFormer, a novel transformer-based model integrating k-means, clustering, and LDA for market basket analysis. This work is a collaborative effort from researchers at the Manipal Institute of Technology. Our research tackles the sparse and dynamic nature of e-commerce transactions, which complicates future purchase predictions. Traditional models often ignore crucial semantic context and customer propensity. KALEFormer jointly models customer tendencies and semantic context to accurately predict the user's future basket. Currently, traditional machine learning algorithms handle trend extraction and segmentation. However, these rule-based models struggle computationally on large, sparse datasets. Furthermore, most deep learning transformer architectures rigidly enforce sequence. Thanks for watching. The code, paper, dataset, and project page are all linked here. The original work is by Xiu Zhu, Kevin Qinghong Lin, and Mike Jiangshuo at ShowLab and US. This walkthrough was put together by Omar Kamal, narrated using the same F5 TTS voice clone that Paper2Video itself uses internally.